If Newton were alive today and saw fossils of Quetzalcoatlus, he would be absolutely stunned because this creature seems to openly challenge classical physics intuition. By all logic, its massive size should make flight impossible. Weighing around 250 kilograms with an 11-meter wingspan, using standard aerodynamic calculations, at the moment of takeoff, its wings should have failed under the stress. But here comes the twist: it could fly, and even cross entire oceans. How did it pull that off? Not through brute strength, but through extreme lightweight design, to push the limits of nature. Its bones evolved to be thinner than an aluminum can shell. Yes, really. The bone walls of this giant were only a few millimeters thick. Inside the bones, the internal strut structure looked shockingly similar to aircraft wing ribs, turning it into a living glider. It likely used a unique launch mechanism, using even a light breeze to catapult itself into the air. A kind of magic that traded fragility for flight. With a body that looked delicate, it ruled the ancient skies. But what truly silences scientists is this statement: if Quetzalcoatlus lived today, humans might still be unable to fully replicate its flight. The issue is not materials or power, but a whole body design that defies conventional engineering. First, we need to clear up a common misconception. Quetzalcoatlus was not a dinosaur and not a bird. It belonged to the Pterosaur lineage, a completely separate evolutionary path to flight. Which means, using birds or bats as a reference may be wrong from the start. For birds, the key is continuous wing flapping. But for Quetzalcoatlus, the real secret lies in the moment of takeoff. That single instant determines everything. For any flying creature, the most dangerous phase is leaving the ground. Bones endure several times body weight in stress. Muscles must deliver peak power instantly. One miscalculation, and the outcome is failure and collapse. Quetzalcoatlus turned the deadly moment into its signature move. The answer lies in its forelimbs, not the wings. Modern birds rely mostly on their hind legs to launch, but Quetzalcoatlus had massive forelimbs with enormous muscle attachments. Its launch style is called quadrupedal launch. In simple terms, it did not lift off so much as throw itself skyward, using its forelimbs to brace and explode upward, launching its entire body like a projectile. Biomechanical simulations show that the power output in that instant exceeded any bird of similar mass, which explains why it barely needed a running start and could lift off in tight spaces. Next, this will completely change how you see giant animals. Staying airborne was not exhausting for Quetzalcoatlus. You might think such size means high energy cost, but the opposite is true. Its massive wingspan created extremely low wing loading. Once it entered rising air, it barely needed to flap, allowing it to soar like a high-performance biological glider for extended periods. Estimates suggest that under ideal conditions, it could glide hundreds of kilometers, making long-range migration possible. The most astonishing part is that it did not fight nature. It borrowed nature's power. But the story does not peak there. If you think Quetzalcoatlus was only an aerial ruler, you are still underestimating it, because on land, it was even more counterintuitive. Bone proportion studies show it had long, stable hind limbs, well suited for extended walking, which suggests it was likely a terrestrial hunter that could fly. Picture the late Cretaceous plains, a towering figure over 4 meters tall scanning the ground like a crane, moving slowly with overwhelming presence. Before prey could react, its long beak could strike, clamp and swallow in under a second. For this reason, more scientists now believe its hunting efficiency on land may have surpassed its aerial skills. What truly sends chills is its physiology. Fossils show a coat of filament-like fibers, suggesting it may have been warm-blooded, with higher metabolism, faster reactions and longer active hours day, dusk and night, all potentially active. CT scans also reveal its cerebellum was proportionally larger than modern birds, granting exceptional balance, coordination and spatial awareness, enough to master rapid launches, precise landings and complex terrain. So, why did this extreme master of flight disappear? The answer is simple: it had no margin for error. Its size, diet, slow reproduction and environmental sensitivity made it fragile in the survival game. When climate upheaval struck in the late Cretaceous, it was already at the edge. The asteroid impact winter was just the final blow. Dust filled the sky and rising air vanished. Flight turned from advantage into burden. The giants that once ruled the sky could no longer rise. The skies were left behind. Small birds and ground mammals survived and took over. One branch eventually became us. So in a way, human existence is not because we were stronger, but because sky rulers like Quetzalcoatlus vanished forever into deep time. That perfect fusion of size, power and flight seems to have been allowed only once in Earth's history.